Hi, hello, welcome to our channel Chemistry Era. This is Anil. Today we are going to learn about intermediate second year chemistry important topic, that is surface chemistry, emulsions. Now, first let us try to understand about adsorption. The accumulation of molecules on the surface of solid or liquid is called as adsorption. Let me try to understand you in a simpler manner. I think all of you have observed the cleaning of board by a duster. When the duster is rubbed against the board, all the chalk powder get accumulate on the surface of the duster. That process of accumulation of molecules on the surface is called as adsorption. The substance on which accumulation takes place is called as adsorbate. Let us define that. The substance which accumulates the surface is called as adsorbate. The substance on which adsorption takes place is called as adsorbent. In the process of rubbing of the board, the duster is called as adsorbent and the chalk powder is called as adsorbate. As chalk powder is accumulating on the surface of the duster, so chalk powder is called as adsorbate. On duster, the chalk powder is getting adsorbed, so it is called as adsorbent. Adsorption is classified into two categories. They are physical adsorption and chemical adsorption. Now, let us try to understand the difference between physical adsorption and chemical adsorption, or physisorption and chemisorption. In case of physical adsorption, between adsorbate and adsorbent there exists a weak van der Waals force, so physical adsorption is weak, whereas chemical adsorption, between adsorbate and adsorbent there exists chemical bond, so chemical adsorption is strong. The second one is physical adsorption is reversible in nature. That means between adsorbate and adsorbent there may be association and there may be dissociation. In case of chemical adsorption, it is irreversible, because in case of chemisorption there exists a bond breaking and bond making is present, so chemisorption is irreversible. Next, in case of physisorption, it is not specific in nature. That means physical adsorption may occur at any case, but in case of chemical adsorption it is specific in nature. That means in order to occur a chemical adsorption, particular temperature, pressure, catalyst and all the requirements are there, so chemical adsorption is specific in nature. Next one, in case of physical adsorption, enthalpy of adsorption is low. That means the amount of heat liberated during adsorption is about 20 to 40 kilojoule per mole only. So the amount of heat liberated during physical adsorption is very less, but whereas in case of chemical adsorption the amount of heat liberated is very high. It is about 400 kilojoule per mole. Next we are going to learn about catalysis. Before going to learn about catalysis, chemical reactions depending on rate of reaction are classified into three categories: slow, moderate and fast reactions. Some reactions are occurring at very low speeds in order to enhance the speed of the reactions. We are using a third substance which do not involve in the reaction. Such substance is called as a catalyst and the reactions are called as a catalysis. I repeat, the third substance which do not involve in reaction but alters the rate of reaction is called as a catalyst, and the reactions which involve catalyst are called as a catalysis. Here catalysis are classified into two categories. They are homogeneous catalysis and heterogeneous catalysis. First let us try to understand about homogeneous catalysis. See the example carefully here. When sulfur dioxide and oxygen are reacting together, it forms sulfur trioxide. If you observe the reaction carefully, the reaction is occurring in presence of nitrous oxide. Here in this case, sulfur dioxide, oxygen are the reactants, nitric oxide is the catalyst. Here the reactants and catalyst are in the same physical state. So we can define homogeneous catalysis as when reactants and catalysts are in same phase, that means they are in same physical state, it is called as a homogeneous catalysis. Now let us try to understand about heterogeneous catalysis. Before going to learn about heterogeneous catalysis, let us see the example here. Here in this reaction, nitrogen and hydrogen are reacting together to form ammonia, and this reaction is carried in presence of iron. Here nitrogen and hydrogen are the reactants and iron is the catalyst. Here in this case, nitrogen and hydrogen are present in gaseous state, whereas iron is present in solid state. That means reactants and catalysts are in a different physical state. That's what we are going to define here. When reactants and catalysts are in different phase or different physical state, it is called as a heterogeneous catalysis. So in case of homogeneous catalysis, reactant and catalyst are in same phase, whereas in case of heterogeneous catalysis, reactants and catalysts are in different physical state or different phases.
Now let us try to understand about colloids. A colloid is a heterogeneous system in which one substance is dispersed as finely droplets in another system. Now let us take the example of smoke. In smoke, carbon particles are dispersed in air. Here the carbon particles are dispersed in air. I think all of you have learned about binary solutions. Every binary solution contains two components in it. They are solute and solvent. In case of colloids also, a colloidal system contains two components in it. They are dispersed phase and dispersion medium. The substance which get dispersed or which is present in minor quantity is called as a dispersion phase. The substance in which dispersion takes place or which is present in major quantity is called as a dispersion medium. Now let us see the example of smoke. In case of smoke, carbon particles are dispersed in air. Here carbon particles are present in minor quantity, so it is called as a dispersion phase, whereas air is present in major quantity, so it is called as a dispersion medium. Now let us consider another example of a cloud. In cloud, water particles are dispersed in air, so water particles are called as a dispersion phase and air is called as a dispersion medium.
Now based on the affinity or based on the interaction between dispersion phase and dispersion medium, colloids are broadly classified into two categories. They are lyophilic colloids and lyophobic colloids. First let us try to understand about lyophilic colloids. Lyo means solvent, philic means loving. Those colloids which love solvents are called as lyophilic colloids. First one, solvent loving colloids. So lyophilic colloids are solvent loving colloids. Next one, colloid salts are directly prepared by mixing substance like gum, starch, etc. In our home we are going to prepare the starch by when we are cooking the food. Our mother is going to descant the starch, but in case of cities and towns they can't prepare the starch, so what they are going to do is they are going to boil the water, and in that we are going to add the starch powder in it. That means these lyophilic colloids are prepared by just mixing. Next one, these lyophilic colloids are reversible in nature, as there exists very weak interaction between dispersion phase and dispersion medium. they can be separated very easily. That's why we are going to say it as it is they are reversible in nature. Next one is they are quite stable. That means they are not much strong, much stable, nor they are much weak, but they are quite stable in nature. Example of lyophilic colloids is starch in water or gum in water. Next one we are going to learn about lyophobic colloids. Lyo means solvent, phobic means hating or hatred. These lyophobic colloids are solvent hating colloids. These colloids can be prepared only by special methods. There is a important method is there which is called as a Briggs-Arcs method. So very different methods has to be used in order to prepare this lyophobic colloids. Examples of lyophobic colloids is metal sols. Sol is nothing but when solid particles are dispersed in liquid, it is called as a sol. I repeat, when solid particles are dispersed in liquid, it is called as a sol. Sol is also example of colloid. Next, these lyophobic colloids are irreversible in nature as they are prepared by special techniques, and there exists a strong interaction between dispersed phase and dispersion medium. So these are irreversible in nature. Next one is these salts need stabilizing agent for their prevention. When you have to preserve for a long time, you have to add a stabilizing agent. That stabilizing agent can be found with the help of a gold number. Next we are going to learn another important type of colloid, that is emulsion. Emulsion means dispersion of finely divided droplets in another liquid. That means when one liquid droplets are dispersed in another liquid droplets, then we are calling it as emulsion. I repeat, when a liquid droplets are dispersed in another liquid, such colloid is called as emulsion. So emulsions are examples of a liquid-liquid colloidal system. That means in this case both dispersed phase and dispersion medium exists in liquid state. Colloids, in that emulsions are classified into two categories. They are oil in water emulsion and water in oil emulsion. First one is oil dispersed in water, which is indicated by O by W, and water dispersed in oil indicated by W by O. Now first let us try to understand about oil dispersed in water, simply indicated as O by W. In this case of oil dispersed in water, oil is the dispersed phase and water is a dispersion medium. That means oil is present in less quantity and water is present in more quantity. Example is milk and vanishing cream. Next one is water dispersed in oil, indicated by W by O. In this case water is dispersed phase and oil is a dispersion medium. That means water is present in less quantity whereas oil is present in more quantity. Example is butter and